Hello, welcome back to 5.4, Completing the Square, the final video in this series where we're going to convert functions that are already in standard form to vertex form, and we're also going to identify the vertex. I'll be part of it too. I did it in the previous video, I just don't think I drew attention to the directions. I'm on page 345 doing problems 14 through 19. So again, I got 6 problems to do here. As always, pause it, rewind it, do what you need to do so that you can understand what exactly is happening. Now, if you saw the previous video, if you're watching them in order, we solved equations by completing the square. Since I had an equation, I had a left side and a right side of the equation. I had x squared plus something times x equals something. So I used properties of equality to solve. Whatever I added to the left side, I added to the right side. Whatever I divided on the left side, I divided by on the right side. Those are properties of equality. Particularly, they're called the addition property of equality and the multiplication property of equality. Excuse me. The big difference for these is I do not have an equation, despite the fact that that's an equal sign. This simply means the name of the function x is the name of the function which uses the input variable x, which is f, is represented by. And I really wish math people would come together and change that. But so far they have not been listening to me. So I'm going to cover this up and I'm going to work just with this. X squared plus 6x subtract 3. Now, this part, the x squared plus 6x, that's what I'm going to make, my arm in the way, that's what I'm going to complete to make my completing the square. I do x squared plus 6x, 6 divided by 2 is 3, and 3 squared is 9. The minus 3, the subtract 3, never went away, and because I'm adding 9, I have to subtract 9. Now let's look at this whole thing. I did this earlier, but let's look at this whole thing. If I cover up this and this, x squared plus 6x minus 3 is what I had. So that didn't change. What changed was this. I added 9, kind of in the middle between the 6x and the minus 3, but I also subtracted 9. 9 subtract 9 equals 0. So all I did was add 0. It just didn't look like I added 0. When I do things where I add 0 or multiply by 1, neither one of those things change what I'm working with. But 0 looks like different things. This is 0 looks like 9 subtract 9. Sometimes 1 looks different, like 5 divided by 5. This allows us to do something called changing the form. So I'm going from standard form to vertex form, but not the meaning or not the value of it. And that's a very important skill. This part right here becomes x plus 3 squared. This part right here becomes subtract 12. That's in vertex form. So I'm going to put the name back to it, f of x. And my vertex is negative 3. Why is it negative 3? Because it's x subtract h. My h is negative 3. And my k is negative 12. While you're still thinking about that one, let's do this one quickly so you can see if we're doing the same thing. So I only got x squared subtract 10x plus 11. Negative 10 divided by 2 is negative 5. Negative 5 squared is 25. Then I'm going to do 11 subtract 25. And I really, I'm cautious of the fact that if I say, or you could do this, you could do this, you could do this, that a lot of times that's very helpful, but sometimes it's also confusing. And I think that if we've seen this before, and we look back on it, we're like, oh, we could have done that too. But also, I got to be aware of the fact that when you're learning this for the first way, I don't want you to get kind of like, you know, fishing where your lure is going to get caught in the weeds, so to say. All right. So one thing you could do is just do x squared, subtract 10x plus 25 minus 25 plus 11. So I could have turned these two things around. That doesn't matter. All right. As a matter of fact, I'll do it. X squared subtract 10x plus 25 minus 25, and then the plus 11 goes there. I think that I just do it the way I do it because kind of that's the way it makes sense to me. But like anything else, if it makes sense to you, it might not make sense to somebody else. So either way is okay. It's fine. I'm just cautious of the fact that now that I showed you two ways, someone's going to email me and say, do I have to do both? No. I get x subtract 5 squared and 11 subtract 25, or negative 25 plus 11. Either way is going to be negative 14. And of course that's still named f of x. Oh, excuse me, that one's named g of x. And my vertex is going to be 5, negative 14. All right, let's do the scary one. There's a couple on here that are scary. These two, actually. You can do it, though. You can handle it. I believe in you. First, I write it without the h of x equals. Come on. 3x squared subtract 24x plus 53. Now, if this was an equation, I would want to divide everything by 3. It's not an equation, so those properties of equality don't work here. Your magic is no good here, all right? What I can do without dividing, but I can factor. So this becomes 3 times x squared subtract 8x. And I'm going to leave the 53 alone. I only want the 3 from the first two parts. Those are the parts that have the x's, the x squared and the x. And again, like I showed you when I first introduced this, 3 times x squared is 3x squared, 3 times negative 8x is negative 24x. So I haven't changed anything. I just factored out a 3 away from the first two parts to get the x squared. Now I'm going to complete the square. This is 3 times x squared, subtract 8x plus something, plus 53, subtract something. What goes here? Negative 8 divided by 2, I'll write it over here. Negative 8 divided by 2 is negative 4. Negative 4 squared is 16. So I'm going to put 16 right here. I will see, I hope not, but I'm almost certain I'm going to see people on the test put a subtract 16 here. What am I subtracting? I'm subtracting 3 times 16, which is 48. 3 times 16. So now let's simplify it. I get 3 times x subtract 4 squared. 53 take away 48, I think is 5. And that is my function in vertex form, which happens to be named, I don't have a lot of space here, h of x. And my vertex is 4, 5. All right. That one's nice. This one's nice. We're going to do another hard one right here. X squared plus 8x subtract 10. X squared plus 8x plus something. Subtract 10 minus something. Because whatever I add here, I have to subtract here. What is it that I'm adding? 8 divided by 2 is 4. 4 to the second power, 4 times 4 equals 16. Now, why did I put 16 here and I subtracted the same thing, 16 here? Why didn't I? Because I multiplied by 1. I didn't have a factor out here like that. So this one's okay. I get x plus 4 squared. Negative 10 subtract 16 is negative 26. That, gotta remember what the names of them are. This is still f of x. And my vertex is negative 4, negative 26. Why again is it negative 4? Because it's x subtract h. Subtracting negative 4 looks like plus 4. Move this up so you can see it. I got my red background for Highland Park. X to the second power, subtract 3x plus 16. Uh-oh. Why am I saying uh-oh? You know why? Because that's an odd number. This is x squared, subtract 3x plus something, plus 16, subtract something. So what goes in this blank right here? What completes the square? Negative 3 divided by 2 squared. And if you've been following along with all my videos, you keep hearing me say you do not have to convert it to a decimal. You don't have to say negative 1.5, because negative 3 divided by 2 squared is 9 over 4. That means I'm going to subtract 9 over 4. Now the only problem with leaving it as a fraction is when I combine here, when I have 16 subtract 9 over 4, I have to then write it as a common denominator. So just keep in mind that 16 is the same as 64 over 4 with a common denominator of 4. So I get x subtract 3 over 2 squared, and 64 over 4 minus 9 over 4 is going to be 55 over 4. And that's my function. And yes, it's got some fractions in it. You can handle it. My vertex is 3 over 2, 55 over 4. All right, finally, last problem. Number 19. I have this 3 in front of it. So first I'm going to write it without the name. Now I'm going to factor 3 times x squared, subtract 4x, leave the minus 4 alone. Now I'm going to complete the square, and I'm just spreading out a little bit to make some space. So if you're wondering why I keep creeping it over this way, that's why. X squared, subtract 4x plus something, subtract 4 minus something. Negative 4 divided by 2 is negative 2. Negative 2 squared is positive 4. Do not put a 4 here. Put 3 times 4, which is 12. Simplify, I get 3 times x subtract 2 squared. Negative 4 subtract 12 is negative 16. This function is named h, and its vertex is going to be 2, negative 16. All right, I look forward to seeing you guys in class and doing more problems like this. Goodbye.